Hello friends, welcome to this video. In this video we will try to find applications of equilibrium equations. As you all knows, in two-dimensional structure there are three equilibrium equations. That is, summation of horizontal forces should be 0, summation of vertical forces should be 0, and summation of momentum should be 0. For any structure to maintain its stability, this structure must have to obey these three equations. That is, summation of horizontal forces must be 0, vertical forces must be 0, and summation of momentum must be 0 at any point on the structure. Now before we do some calculations and some numerical problems, you have to remember first sign conventions. These sign conventions are very easy. You have to remember that if there will be downward force in any member, it will be negative. We will take all downward forces as negative, and we will take all upward forces as positive. This is easy. Now for calculation of momentum, we will take this as positive and this as negative. It means if there is a beam and for momentum will try to rotate it upwards, we will take that momentum positive. Suppose if this is a simple beam and there is momentum in anti-clockwise direction and there is momentum in clockwise direction, we will treat them as positive because both of them will try to rotate beam upwards. And similarly, if momentum will try to rotate beam downwards, we will take that momentum negative. Suppose here momentum is anti-clockwise direction and here momentum is clockwise direction. We will take both these momentums as negative because these are trying to rotate beam in downward direction. You have to remember these sign conventions and these three equations. Now let we start from a simple example. This is example. I already write this question. So determine the reactions on the beam shown in the figure. You have to determine reactions on the beam. Here it is a hinge support and this is force and this is a given momentum. Here this is a roller support. Now free body diagram of this beam is given. This will give two reactions, one reaction in vertical direction and another reaction in horizontal direction. And this is 60 degree 60k. It makes 60-degree angle with horizontal. It will have two components, one in vertical direction and another in horizontal direction. So I take two components of this force. And this is a roller support. It will give one reaction. It is I write this reaction py, and here momentum is given, that is 50k feet. Now let me find these unknowns. So we can find them easily with the help of these equilibrium equations. First equation says that summation of vertical forces equals to 0. Let me apply this equation first. What are the vertical forces? Here are one vertical force, two vertical force, and three vertical forces. I can write ay, this is upwards, plus by, this is downwards, so minus 60 sine 60 equals to 0. So I can write it easily, ay plus by equals to 60 sine 60, which comes out to be 60 sine 60. It comes out to be 51.96. So we can write this as equation 1. Now we can write another equation by using this equation, that summation of horizontal forces must be 0. So here are one horizontal force and second horizontal force due to this component of this force in horizontal direction. So we can write, and you can take the sign convention for horizontal forces. You can take this direction as positive and this direction as negative. So we can write ax minus, because this is in negative direction, 60 cos 60 degree equals to 0. Or you can write ax equals to 60 cos 60, which comes out to be 60 cos 60, it is 30. So from this equation, ax is 30, so this comes out to be 30. Now you can now you have to use another equation. Now what is our another equation? Another equation says summation of momentum must be 0. So we take momentum at this point. We will say summation of momentum at point A equals to 0. Summation of momentum is 0 at every point. We will take this point. Now you all know what is momentum. Momentum is force into distance. First, momentum due to ay at this point is force is ay and distance is 0. It will be 0, and due to this ax, momentum at this point will also be 0. Because ax into distance is 0. Now what is momentum? That is at a, it is minus 60 sine 60 degree into distance, it is 10. It is negative because it will try to rotate this beam in downward direction. And this 60 cos 60, it is another force, and because distance is 0, it is passing through the center. So momentum because of this force will also be 0, because momentum is force into distance. Force is passing in this direction and distance is 0, it is passing through this point. And plus, because it is in upward direction, it is positive. It will try to rotate beam like this. It is positive. So this will be by into distance is 14 feet, by into 14. And last one, this is this will try to rotate beam in downward direction, so that is negative, minus 50. It must be 0. Now you can say by into 14 equals to plus 50 plus 60 sine 60, it is 60 sine 60 plus 50, it is 101.96. so you can calculate by easily. 101.96 divided by 14, that is 7.28 K. Now you have calculated this by. Now you can calculate ay easily. You can substitute by in equation 1 and you can get ay. You can get horizontal reaction at A. Now I will substitute by in equation 1. So I will write by is 7.28. Now I will substitute this will come 569.65. so if I divide this by 14, it will come 40.68. so this is 40.68. now you can substitute in this in equation 1 and you can get ay easily. Ay is 51.96 minus by is 40.68, so ay will come 51.96 minus 40.68. 40.68. so it will come 11.27. so ay is 11.27. now let me try to solve another important example. This is the example. Determine the reactions on the beam. So beam is given, you have to find reactions. Now I can write this, this is a triangular load and rectangular load. I can separate this. I can write triangular load and rectangular load. Now I will try to first I will try to draw a free body diagram of this structure, of this beam. Here this is fixed support. It will give three reactions. One reaction in vertical direction, I will write AY. Another reaction in horizontal direction, in this direction I will write it AX. And it will also give anti-clockwise momentum. Anti-clockwise momentum. MA. This is point A and this is B. But there is no, not any support. There will be not any reaction or now this is point A, this is point B. Now this is a first this is one, this is a triangle. It has base 12 and it is height is 10. So I can write an equivalent force from this triangle. I can write from this triangle it is equivalent force will be, it is area, that is 1 by 2 base is 12 into height is 10. So I can write 60 K, sorry, 60 Newton will be the force due to this triangle. But I will put it h by, I will put it at a distance this base by 3, base is 12, so base by 3 is 4, so I will put this at this distance 4, so it is 60 Newton at a distance of 4 meter. Now this is a rectangle, it has 12 meter one side and another side is 4 meter. So force due to this rectangle will be, it is area, so it is 12 into 5, it comes out to be 60. It also comes out to be 60, force due to rectangle is also 60 Newton. Now I will put this 60 Newton at half of the distance of half of it is base distance, so it will come here 60 Newton. This is 60 Newton, this distance is 6 meter. Now let we start our calculations. First calculation says, first equation says summation of vertical forces must be 0. So I can write AY minus 60 minus 60, because there are 1, 2 and 3 vertical forces equals to 0. Here simply AY equals to 120 Newton. So our AY is 120 Newton. Now another equation says summation of horizontal forces equals to 0. Here only one force in horizontal direction is AX. We can write it simply 0 because there is not any another force. So AX comes out to be 0. Now we have to find this momentum. Another equation says summation of momentum at any point we will take at A must be 0. At A I will take this as momentum MA dash. This is summation of momentum at A equals to 0. Now let we find the summation of momentum at A is, due to this MA dash it is negative, minus this is also negative, minus 60 into distance is 4, minus this is negative also 60, because it will try to rotate this beam in downward direction, minus 60 into 6 equals to 0, which further implies MA dash equals to 60 into 4, that is 120, plus this will become positive 60, that is 360. So momentum MA dash will come 360 plus 120, that is 480 Newton meter. So this is our MA dash, it is 480 Newton meter. Hope you understood this. Thanks. In the next video we will try to solve some more examples. Thanks.